Okay, so we've talked a lot about the trig functions, how we can think about them as a ratio of two sides of a right triangle. Um, then we went and we looked at them in general, so what the trig functions were for any particular angle. So now what I want to do is I actually want to plot the functions. So on the horizontal axis, we want to plot the angle, and then on the vertical axis, right? Think of it as the y-axis. We're going to plot the actual function, and I'll just focus on sine, cosine, and tangent. Okay. So actually, there's some nice animations that people made um, on the web using the software called GeoGebra. So let me show you these animations. Okay, so here I have my unit circle, right, which we've been talking a lot about. Remember the unit circle, in some cases we use just r as our radius. In this case, the radius is set equal to 1, so it's a unit circle. And we have a slider here where we can vary the angle between 0 all the way to 360 degrees. And I want to plot the sine function. And remember what the sine is, right? By definition, it's the y divided by r. But since the r here, since it's a unit circle, the r is always 1. So the sine is just going to be the y value. So right now, when I have 0 degrees, what is the y value? It's 0, right? So I'm plotting 0 here. As I start increasing this angle, so like at 24 degrees, the y value is 0.407. So sine is going to be y divided by r. So that's 0.407 divided by 1. So that means the sine is 0.407. So at 24 degrees, I'm plotting that 0.407. And for each angle here, I'm plotting a different point. And if you keep doing that, here's where you're going to get that familiar like sinusoidal shape, right? It's going to oscillate back and forth. Remember at 90 degrees, right, the sine is equal to 1, exactly 1. And then if I keep going, right, it starts decreasing because that y component is getting smaller. It's still positive, but getting smaller. Then when I go past 180, it'll become negative. Remember at 270 degrees, right there, the sine is -1, right? So that's what we're seeing. And then in the fourth quadrant, it's still negative, and it gets smaller and smaller and smaller, it goes back to 0 again. And I'm plotting just one cycle here, but in theory, I can keep going around, right? Remember we talked about like having co-terminal angles where it's the same angle. You could go around either clockwise many times as you want, or counterclockwise, and counterclockwise would be going this way, be negative. And this cyclical graph will just keep going on and on forever. It'll keep repeating. Okay, so really that's where it comes from. It comes from plotting the function, right, the trig function, as a function of the angle on the x-axis here. All right, so that was sine. Let me show you cosine. So remember, cosine is defined to be x over r, right? Cosine of theta is x over r. So if the angle is 0, the x is 1, r is always 1 because it's a unit circle. So 1 divided by 1 is 1. So it starts off at 1, right? When the angle, remember, this is the angle. So when the angle is 0, cosine is 1. Then as I increase the angle, my x value is decreasing, but that is the height here. That's going to be my cosine, right? So 48 degrees, my cosine is 0.669. And at 90 degrees, remember the cosine, that was one of the special cases, it's 0. Then it becomes negative, right? Because the x component is negative. And again, you can keep doing this and you're going to find it looks just like a sine wave, except it's shifted and it oscillates back and forth, right? And it'll keep going on forever in both directions. And then tangent, remember tangent was sine divided by cosine. So this one's a little trickier to see here, but the way I kind of like the way that they did this. So sine divided by cosine, or y divided by x, right? By definition, it's y divided by x. So in this case, the y is 0, the x is 1, right? So tangent of 0 is going to be 0. So it starts at 0. As I start increasing this, notice how it's plotting this line right here. Like if you extend this radius where it meets, it forms a right triangle. Remember, tangent is this value divided by, and this is always 1, this x is 1. So in this case, it's a nice way of representing the tangent function, right? You can think of it as opposite over adjacent, where the opposite is going to be this side, where when you extend this, and then the adjacent will always be equal to 1. In reality, it's the y value of this point divided by the x value of this point, but since they're similar triangles, it's going to be exactly the same ratio. So just a nice way of illustrating it. Now look what happens as I get near 90 degrees. Remember, it's sine divided by cosine, right? So I'm going to divide by 0. So actually at 90 degrees, it's undefined. So it rises up, it goes to infinity. And I actually have a vertical asymptote there at 90 degrees. Then it becomes negative. It rises back up at 180. It's 0. Becomes positive again. Then there's another vertical asymptote. Jumps back up and so on. So that's what the tangent function looks like. Actually, let me show you all three now together. So here's a case. Here the angle is in radians. So this is in radians. And this is a sine function. So again, it just oscillates, right, forever in both directions. They're showing from like negative 4 pi to 4 pi. If you want to see particular values, actually, these are kind of fun if you want to play around with these. If you click on special angles, right, let me start at 0. Then we can kind of see the special angles that we went over in class, right? So sine of 0, which is 0 radians, 0 degrees, that's equal to 0 right here. If I click on this, remember 30 degrees or pi over 6 was a special angle, that's equal to a half, right? So this is 0.5. So it's just giving me the special angles. Sine of 45 degrees or pi over 4, that was radical 2 over 2. And then sine of 60 is radical 3 over 2, and so on. So you can do all these like special angles here. Okay, we could go to, let's go to cosine. So remember, cosine started at 1, right? And again, it oscillates forever. In that last demonstration, we only showed one of these cycles, right, from 0 to 2 pi. But here it just keeps going in negative. If we look at the special angles, let me set this at 0. Remember, cosine of 0 or cosine of 0 degrees is equal to 1. Cosine of 30 degrees, which is pi over 6, that was radical 3 over 2, and so on. So you can get all the special angles. Remember, in the second quadrant, right, the cosine was negative, right, because the x value is negative. And then tangent looks like this. And again, you have all these vertical asymptotes. Let me do the special values. Start at 0 again. So tangent of 0, right, 0 radians equals tangent of 0 degrees. That was 0. And then as we went to the right, tan of 30, which is same as sine of 30 divided by cosine of 30, that was radical 3 over 3, and so on. And as we get closer and closer to 90 degrees, it goes to infinity, and right at 90 degrees, it's undefined, right? Because you're dividing by 0. Because remember, it's sine of 90, which is 1, divided by cosine of 90, which is 0, and that's undefined. You can't divide by 0. So at all these, you know, at radical, at pi over 2, and then 3 pi over 2, and negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, at all those points, we have these vertical asymptotes. And if you want, you could play around with some of the other functions. We don't use these as often, right? But remember, cosecant is 1 divided by sine. So actually in the dash here, they have sine. And if you do 1 divided by sine, you're going to get these purple graphs. So that's the graph of cosecant, which is, again, periodic. It repeats, right? It repeats every 2 pi, you get a copy of itself. Okay, and then you can play around with the other ones. So that's all I wanted to talk about, just in general, so that you recognize like where those these periodic functions come from. They just come from plotting the function, you know, the trig function as a function of the angle. When the angle is on the x-axis, the trig function is on the y-axis. And notice that here, the largest, right, the largest that sign can be is 1, and the smallest it can be is -1. So it varies between -1 and 1. That would be like the range of the sine. Same thing with cosine. It ranges between -1 and 1, but tangent can go from -infinity to infinity. All right, again, I think that's all I want to talk about for this part. Great, thanks.